Let's try this again. This is where we left off last time, and I wanted to go a bit deeper into that today. But first, let's get a few things out of the way. I'm still juggling windows here. Okay, tea. After 3 years on the boat, I finally bought a kettle, so let's have some tea. And that nice cup, this has to be the worst teapot ever, so I'm trying not to make a mess and spill everything over my notebook. But nice hot tea. Hot, 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 hot. Hot, hot means less coughing, I hope. Um, since this is not a scheduled stream, no fish today. Um, yeah, we'll get into fish hopefully next week. Also, schedule already changed a bit, so might be the week after. Um, Still no microphone. I'm super sorry. I used my lunch break to go to 3 different stores, and nobody is selling microphones or headsets or anything like that. I was close to buying a webcam just because it had a microphone included, but then realized, hey, wait a second, that has a USB-A connector, and I don't have any USB-A anymore, and I don't want to get back into that. The stream network quality. The video quality at 720p was actually quite surprisingly good, and everything was readable when I rewatched the stream. Apparently, there were some network dropouts. That's why I started earlier today. I hope while everybody's still at work, the Marina Wi-Fi will be a bit more stable. It's just another try, and if this doesn't work out, we switch to 4G. But let's check that first, and then while rewatching yesterday's episode, I realized sometimes the mouse pointer in the stream was strangely offset. Right now, it seems to be correct. I'm just at the beginning of the line here, and the end of the line, and the top of the script, the editor. So it seems to be good for now. Um, I have no idea what happened there, but if you were totally confused because I pointed at stuff with the mouse pointer and the mouse was somewhere totally different, that might be the reason. Just do a mental offset and rewatch the video. And yeah, plan for today, apart from drinking tea with you, still too hot. That smells nice. Is peek into the source code of 64, and I hope this works. I have to juggle windows and bit space restricted here. I really need a second screen if I want to keep doing this from the boat, but bear with me. So we're getting out of this editor. I'm not going to see it again. This is the tool, as you remember, and it's exactly where we were last time. And today I wanted to go a bit into these operators here. I mean, as you can add various different ones, and we'll look into these. So let's dive straight in. What if you right click here, you set the original node where basically the execution starts, and you see if I mess this up, I get some weird artifacts and nothing works anymore. So let's set the main entry point back to the main, but it's good to quickly test only some subroutines. And let me check if the mouse pointer is correct. We seem to have a weird mouse pointer offset again. Right now I'm on the engine button. Oh, it's only a few lines, so yeah, it's quite a bit, and I have no idea. It actually scales weirdly because this is on the engine button, and then the stream is on the texture preview now, but I'm on the texture preview now, so pointing will be a bit tough. But you can see a performance counter here. This is current frames performance. And this down here is the recent frames performed. And you can see if I switch to different parts, if I render everything, it will use about 1.9 milliseconds on average, which is pretty fine, but we're rendering nothing. But back to the node. So this label here is technically not needed. We could just start here, but I like to have my main. So this is a subroutine node and a subroutine. Oh, now this is going to be funny. This yellow bar here and the mouse offset is just broken again, and I can't even see the mouse offset you're seeing. So this will be very interesting. So this here is the name of the label. And you see we have a subroutine for the background here and the gradient. Then we have the call function. And the call function, it's basically call a subroutine. So this calls a subroutine called background, and this is actually here. So you see the nice pink arrow. Well, it helps to understand what's going on. We have another call. So this jumps here, execute, and as soon as it hits an empty node or in the future return or something like that, it will jump straight back here. You see same here for the gradient, goes through here, jump back. And then we have this frame buffer target. So if you have a frame buffer target, we bind the named frame buffer. And if it's empty, and this is historic, and this is actually the name that's used, if it's empty, it will just use the default target. And we have to do that here because in these subroutines, we play around with the frame buffer and frame buffer targets a bit. So, and then we just call the combine. And then it's just for... we could just put this whole block right here, but it's easier to manage this way. And again, we have a subroutine here, which is again just a label. Then we have a pipeline here. And a pipeline is basically, right now it's two shaders. This should actually be replaced by a shader node. But for simplicity, we said we only have a vertex shader and we have a fragment shader. And this is a open file dialog button, which obviously is not going to work since this is a window capture, not a screen capture, so you won't see anything. But you can also just type in the name and it's relative to the project directory. And last time I also showed you the debug screen for this. Ignore this. We'll go into that node by node later. We have this uniform node, which basically sets a uniform for the currently active pipeline. So it needs to know which shader, in this case the fragment shader, it needs to know the uniform name, and that has to actually, let me go into Sublime, this is a background fragment, that has to match the uniform name. So it just does a lookup by name, which is suboptimal, but we didn't want to go into position-based lookup there. So let me go back here, and then the same for the aspect and the same for the offset. Interesting point here is this here is actually a very simple, tiny expression language. So you see, you can just add values. I could also I can multiply. So if I do a quick parse, you see down here in the console, you see the result is 2.0. Or I could do a plus here, and then the engine instantly uses this value, so I can test various values. So on when I type, it recompiles, and as soon as it has something that it can actually parse, it will use it. But I can press the parse button here and then get some info. So this is the intermediate language that's used. So it's a stack base. It's going stack based, so it's pushing a float 1.0 to the stack, then it pushes a float 2.0 to the stack, and then pushes an operator plus to the stack, and the result is 3.0. But let's put this back to 1.0 for the moment. And then it can also do stuff like look up variables. So $time means use the variable time, and that's here in the variables window use $time. So I'm not sure if the parser will do this. Actually, it does, so it was at 7.93 at that point, and also I could just combine stuff and say, hey, plus 1.0 or times 5 or times 50 plus. So, for example, I could tweak this speed with this, and then the offset uses it also has commands, and actually the synchronize command says, hey, whatever, oh, it's not in here anymore, whatever is in the timeline in the column currently interpolated or not interpolated, depending on, remember the interpolate check mark here, use that value, and we can also do arithmetic on this, and obviously it's gonna totally overshoot, but there's multiplication and stuff, so yeah, so every time we enter a value somewhere, it's actually this tiny expression language, and as you see, the compiled version is super compressed. We have the frame texture, and it's always these little shortcuts, as you can see here. They're super short. And we have frame buffer, which creates a frame buffer. We have frame buffer target, which means render into a frame buffer from now. And we have frame buffer texture, which means use a frame buffer target that's existing as a texture. This whole thing is built to be super tiny, so this whole thing needs to be super tiny, and these graphs usually can be pages and pages and pages long and wide, and can get pretty complex. So we're just saving space here. So you get, when you get used to it, you can read it pretty quickly, and if not, you just hover over it and you get the short info and even some debug info. And if you need the longer version, you can always hover this little question mark and get a little explanation. You can also see there's some legacy fields in there that are intentionally left in, because when you load an old project, it will populate the old fields, and then you can just load in the old project. It will highlight the nodes that are old style, but you can still have the old value for reference, and then just put it in the new one. The plan was to have it like an option button to disable legacy loading, but we never got there. So yeah, we have the frame buffer target background, which means use the frame buffer called background. That's the one we created up here. Use the attachment index 0, and quick sidestep here. The frame buffer obviously has a name, it has a side. This also can be calculated or be variables and stuff. The color types is old. We have explicit 4 color types now, so it could be RGB 16 float or RGB A8888 or U8 or whatever. We're currently using only RGB 16 float, and I could just put a second one here, and then it would have 2 attachments, and then obviously I have the depth type. Usually that's 8-bit, and then the stencil type, or it's 8-bit or 24-bit, and then we have the stencil type, which is currently none, I believe. Yeah, so we have stencil type 8 or none, and defs type 24, and they will actually be combined into defs 24 stencil 8, because OpenGL has a special mode for that. So basically back here we're saying use attachment 0, and if we look it up here, and we really need this arrow thing here on tooltip that tells me, so use this one here. And then we don't want to use the defs and stencil, we just ignore it. Texture ID again is legacy, and we use the sampler channel, and then caveat, don't forget the sampler channel, we are uniform, and that's just the way OpenGL handles this. So we say, hey, this is channel 0, and basically same here. This is channel 1, and we say the texture sampler, which gets us to we have the uniform float up here. We have the uniform int here. So it basically says, say, in the fragment shader, get the uniform texture sampler and just set it to 0. And that tells OpenGL to use texture channel 0. And and same for the gradient. So the gradient sampler uses texture channel 1, which is this here. And if I quickly go back to Sublime, you see here's the two samplers. So pretty straightforward once you get the hang of it. Usually what we do is we just copy the old project, and then just copy blocks, because you can just like copy and paste here and move stuff around. I'm not going to do that because I don't want to touch the file. And then just render a full screen quad. So this just renders one full screen quad with the current textures and everything. So we have plenty of nodes here. Let me see. We talked about the subroutine. We talked about the call subroutine, and they're intentionally not sorted alphabetical. We talked about the pipeline. The uniform color is a bit special. So the uniform color is it uses name as a prefix. So if I type color here, it will set color underscore R to this value, color underscore B to this value, and color underscore G, so RGB to this value. And the nice thing is I have this little thingy here. Actually, this will break for the moment, but let's put the color here. And actually, let's go back to Sublime just to show we want to uniform float color. I think it's underscore. This should be an array, but we want to keep the runtime small, so we reuse as much code as possible. I hope it works like this. So we have this, and then we just let's just. It's a bit clumsy, but this text down here compresses really well, while code duplication doesn't. Oh, obviously, I could look into the 64 window, but I don't know what's going on. So let's just add this. So obviously, all these default to 0. So we're seeing nothing. I have a Sublime license, which I actually need to add. So let's get back to the tool and let me check something in the source code real quick, because I haven't used this in years. Let's just use a nice red. I'm not sure what's currently going on. Buggy. But you get the gist. Let's just pull this out for the moment and move these down here. So we have the color node. We have the uniform float. We have the uniform int. We switched to using only the float, but there were reasons to use the int. Yeah, so therefore, historic reason, we have a text. I didn't want to add the texture here. We have a texture which we actually use here. So you just name the texture, and you can actually tell it if it's RGB sRGB or not, and you see a slight change in the. It's not important for this texture, but the color space handling is important. We have the frame buffer that we create up here. We talked about that we have a frame buffer target, because this could be one node that just says use the last created frame buffer, but we might reuse it multiple times. For example, we do a blur, we just create it once, but we use it 15 times or whatever. So there's a create and a use as a target, and then there's obviously use as a texture. We have the full screen quad, and then we have actually the set float. So the set float is interesting, and I'm just gonna put this here, and as you can see, you can set variables. So I can set a variable called, I don't know, maybe I want to, and this is a bit ugly because it's a bit over fast. I want to calculate the aspect ratio based on the viewport dot x, and obviously I have to, I'm not sure this will work, divided by the viewport. I think the dot will not work in the variable name here because it's not valid, which is interesting. Yeah, so it gets stuck parsing. But yeah, we can just. This needs a fix, so it calculates stuff like that. Or you can, if you use something all over the place, you just calculate it once. So let's remove this, and then we have the same for U in 32. One of the first intros we did with this was a 4K, and we used the bit mask to trigger certain stuff, and it was much easier to do that with U32 than with floats. We have this section, and actually we can do this, and then let's put a section node here and call this section background. And as you see, the color down here changed, and then let's move this here and call this section combine. And it's intentionally not based per subroutine because that might create too much noise. But let's put one for the gradient here too. So, and the performance count is actually one of the last things I added. So let's call this gradient. And as you see here, you can see now the background is taking, oh, my screen is too small. This is how much time what stuff takes, and that's important for seeing where your performance is going. And actually, as you can see, this green bar down here that turns yellow somewhere here. I hope the mouse is in the right area, mouse pointer. This means we're still hitting first frame. So 60 FPS, and then this yellow is still 30 FPS, and it's actually off screen because we never go there. We hit 60, and then it's just interesting how far we go here. And this down here is basically the same data, but it shows you if we peak at certain points or stuff like that. So that's the section node, and then we have the non node, which is basically a knob, which is nice for debugging this stuff. And yeah, that's it. So we still have this dialog opens behind the renderer, so I stop this and just say file save. And then we have, for historical reasons, you can also dump this whole thing to JSON. And you could also restore it from JSON, which we're not gonna do. And we have settings in here which set certain stuff, and you can tweak the colors and the default paths and whatnot, but I'm not gonna go into this right now. And then we have a open and change where you can actually get a file chooser. Well, open has a most recently used list, so I could just say, hey, these are the last projects and pick one of them, and then obviously the package, which creates this nice one file blob that is usable by the runtime. I wanted to show you the runtime, but the bandwidth here was not high enough to update to the correct Rust version, so sorry about that. I will close this for the moment because I will let this run in the background and just pause it. Is it paused? Yeah, it's paused. And switch to Visual Studio. And switch to Visual Studio. So Visual Studio, and you see much more than I do right now. And this screen is far too small. So this has grown organically, and it started out as a tool to write 4K shader-based intros, so very tiny, very compressed, very don't pull in everything you don't want, and then it ended up being an in intro editor, and then the tool with all the fancy UI was based on this, and you can see this all over the place. And this was done at parties, so party coding, usually totally sleep deprived, other things too. I'm gonna stop the engine in the background for the moment and push this down here again. I hope you still see, and as you see, Visual Studio still, this just gives me a bit more space and a bit more performance. So I want to go over there's lots and lots of stuff to talk about, but I want to go over this op grid thing. And we have this operator grid, which is basically a grid right now. It's even fixed size, which has various cells, and lots of helper functions, but basically every cell can either be empty or have something in it. And I want to go into the individual cells right now. And the cells, the UI you saw is just configuration. There's no code per cell type behind it. It's just configuration. We go into that, and then there's this later, not today. We look into this cell runner, and the cell runner basically has a run through the cells in the correct order and do the right stuff, and then per cell type we have for example, here's the call subroutine. Per cell type we have a subclass for that runner. So this is the call subroutine. This is the frame buffer. This is the frame buffer target, and so on. So the runner will run through instances of that and just pass in the op VM and do all the build up and shut down, and actually the replayer runs this totally different, and this needs to be unified. But again, we're looking into the op-grid cells here, and as you can see, what we just talked about, we have this types that we just talked about, and there's a subroutine, the call subroutine pipeline, yada yada yada, the frame buffers, the set floats, the section, and the none. So whenever sorry for scrolling here, but this is just a lot of stuff. We can create op-grid cells by type, or we can just say this is basically legacy, which isn't actually used. So right now we just create by type, and obviously have a constructor by type, and then we can get the properties and set the properties and remove the properties. And runner data has to do with the op-grid cell runner, which we're not going to get into, and then we can serialize it to JSON and from JSON, which is the old school JSON serializer you saw earlier. And then obviously we have an assignment operator. We have the type configs, and I will go into this in a bit. Let me have a sip of my tea. I know I'm going super fast, we're cover a lot of ground mode and to get some ideas planted, and then we'll dive deeper into them one by one in the future. Stream seems to be stable today, so yeah. So we have the type of the subroutines, and then we have this properties, and properties have types again. So we have floats, strings, files, colors, and booleans. And then we have the type hint, which I'm not going to go into today. Basically, a property has a type, a name, and a value. And name and value are always strings. Just to be super generic here, it has getters for name and values. It has a shortcut getter for, hey, give me the boolean value, because we don't want to constantly parse and parse and parse. We can get the type, we can set the value, we can set the boolean value, we can serialize to JSON, and we can serialize from JSON, and that's the types. And then we have a type property config. So we have a long list of properties, and this is actually how the property looks like in the editor. So this is actually an instance of the property, and this is every cell type has multiple properties, and this is the configuration for that. And the visibility can be visible, deprecated, hidden, or deleted. So sometimes we deprecate fields. That means they're still there, but they will not be written anymore, not be used anymore soon. Then they're hidden, and then they're deleted. They have names, they have default values, they have types and type hints. They can have up to 10 values, 10 pre-configured values, the visibility, and then they just have constructors, and this is a bit ugly. I'll go into why in a moment. And then we have type configs. So this cell type, an operate cell type is configured this way. So it has a name, it has a tag, that's the short version you saw. It has a description that's used for the tooltip. It can have up to 12 properties, again, hard-coded magic, because the runtime just assumes fixed layout. The editor layout ratio is probably, maybe it shouldn't be here, but you saw, for example, for the color attachment, we had 4 in the row, and that means we could use 25%. Default is use 100% of a row, and then it just has a number how many properties are used. And we're in the property class right now. No. Oh, this screen is too small. Yeah, so we're in the type config now, and then obviously we have a static that says initialize configuration. That's the interesting part we will look into, and then add config entry, and then add config entry property. This was initialized statically with static constructors, but Visual Studio had problems with sub constructors in initializers, so we went as explicit. We looked into the create by type. Let's look into this initialize config. So ignore the test up here. So the initialize config calls add config entry, and the formatting here is a bit peculiar, but I'll go into this. So it calls add config entry, and then says its type subroutine, its name is subroutine, its short tag is subroutine. This is a multi-line description. And then it says for type subroutine, add a property that's called label. Default is anon. Don't ask why anon. By the way, this is a string and uses 100% of the line. And actually, I do want to start this again. So we just looked into subroutine and create a new. Let's create a new subroutine. So it's a subroutine. The short tag is SR, and the default value is anon in label, and that's exactly what we just saw in Visual Studio. And I have to juggle windows here. I'm sorry. And trust me, I'll just close this in the background and stop it here. I'm totally messing up my setup. So then we have another config entry, and that says call subroutine. And same, this is a label, the name, this is a short tag, and this is a description. There should probably be a description, and it has one property. That's so called subroutine has one property called target label with no default, and it's a string and uses 100%. And then we do the pipeline here, and the pipeline actually has two. It has one for the vertex shader and one for the fragment shader, and the default value is default vertex and default fragment. And the property type is file, so we get this nice little reload and debug and stuff. And then uniform color. Well, it has a shader type, it has a name, and has a value. And again, these are just the value is actually color, which we just saw. Same for the float, same for the int, and frame buffer actually gets a bit more complex as you can see, but only because the description is much longer. And now you see why we're using raw strings here and why everything is left aligned to avoid zigzag code. And can I make this a bit bigger? I cannot. Okay. Yeah, there's a name and the width and the color attachments. And the first two are defaulted to RGB16F and the other two are not. And here you can see the 25% I mentioned. So it will, when the editor renders these things, it will just say, okay, I render the first one and remember how much of the line it used. And when the next one doesn't fit into the same line anymore, I just use a second line. And here with the width and height the same, they just use 50%. So it's a very basic layouting, but it means I can just add an entry here and it will just magically appear. So all I have to do, it will not work, but it will appear. And I think we're actually going to do that. I mean, no need to go through all these add more, but these add more, and then actually the add config entry just creates a config and fills out the proper sets the properties to none. So this is just the global. This is just the config, and this type configs is just a global array. Yes, a bit ugly, but again, low overhead. Same for the add config entry property. So it goes to the config, gets the property config part of this struct. So if we go here, this struct has the properties, and that's just a look up here. I'm not sure. No, really? This is not const. None of this is const. So what the hell? Well, okay, ignore. It works. Why don't we just okay, let's go to the header file. Why don't we just add a new thingy here? So I want to, it was always on my list, so I want to add a mesh that comes from an OBJ. So step one, I add this here, will change nothing. The thing knows nothing about it, but if I go in here now, let's be a bit clean. So what do? I say add config entry, and it's all grid cell type mesh obj mesh dot obj. We set a nice label, and the short tag will be ob. I wish we had started with 3 letters, but it was too late by then. And then we do the raw string here, multi-line, and obviously it needs the braces. And then render mesh from .obj file. Oh, sorry. So this right now, I'm not sure why. Oh, my bad. So let's compile this. I'm not sure why my Windows machine is compiling that slow. This editor already also runs on a Mac, and it just, yeah. Let's not get into time to drink some tea. I'm not sure why it's compiling everything. This should be an incremental build, and ignore all the warnings. That's why we started with some special magic to get small binaries. So let's start this. And yes, you can see this. And if I click here now, oh, we have the OB. Mesh obj, render mesh from an obj file. And I can click it, I add it. And as you see, it doesn't have any properties, which is a bit sad. So let's fix this. But all we did to add this new cell type is add the new type in the enum and add a config for that. But I want more than that. So add config entry property. Why is autocomplete not working? Okay. My autocompletion is totally messed up. No. Mesh obj. And what did we call it in the other cases? Probably file name. I just want to be consistent. So file name. Default is none. Grid cell. This is so much easier when autocompletion. Cell type is type file, so we get the nice file selector, and it just uses 100%. And we could think about stuff like adding a scaling factor or saying use material or flip Y for some editors don't have Y up. Let's pour some tea here. This tea is actually good. This pot is lousy. So again, we added one line here. Let's compile it. That was fast. We run it. And let's try again. So we add the obj node, and you see we have this line here, and I'm gonna I can see if the mouse pointer is in the right spot, but I'm going to click the little triangle here, and the textures need to be fixed. And there seems to be a bug. What happens if I... The file open doesn't work in general, so we broke it probably a while back. But this would just open it, but I can also just say, hey, cube obj, and this is it. What I can even do is I can say, hey, save this now. Let's close this. And Visual Studio is doing a full dump in the background and a leak analysis. That's why I have to stop here too. And if I restart now, it loads the same project and it's still there. So the serialization is also completely independent of the new node. Obviously, this new node does nothing yet. And when I run it, let's stop this. And I'm going into, let me take you with me here. I'm going into Visual Studio. And then we have the off-grid cell runner. What's a key in Visual Studio to open the other so I'm getting file open dialogues here and that you don't see, but I'm going into the off-grid cell runner here real quick, and this is nothing we will do today. And you see here is the create for type, and the default is the knob here. And if I push this back again and go here and press play. Oh, it actually I do the down up. Yeah. You see nothing. So there's more hooking up to do. We're gonna ignore this for today. So it's super easy to hook up a node, and actually I might start to implement that node and go into the next time. But we aim for 30 minutes today. I think we're about, I don't know, 45 minutes in. As usual, shoot me your questions. With the current setup, I cannot see the chat live, which is a pity. Yeah, I hope you still like what we're doing here. I hope I inspire you to work on your own tools and steal some stuff. And lesson probably for today is work a bit data driven. So use the configuration and let the magic happen in the code. So, but that might be a bit of overhead for the first cell type and even for the second. But once you have like 10, 15 and add one more, it saves you a lot of time. Stay safe, and I hope the audio wasn't too bad today. Bye.